Today we're going to add vectors mathematically rather than graphically. And so I'm going to start off with an example problem that we could do graphically. So let's say we have a displacement vector A, and let's say that it has a value of 20 meters and an angle of 30 degrees. And then let's say we have, I want to add to it vector B. And let's say that it's 10 meters at 70 degrees. Okay? Now, if we were to do this graphically, and I'm not going to take the time to do it perfectly, you know, I'm not going to get a protractor out, I'm not going to get a ruler out or anything. I'm just going to do it, just do a hand sketch. Here's my X and Y axis, so I'm going to add these graphically, but just as a quick little sketch. So this is 20 meters at 30 degrees, so there's a 30 degree angle. I'll say that that's 10, 20. And then this is 10 meters, so it's about this long, but it's at 70 degrees. So it's a little bit short. I might have made that a little bit longer than it should have been, but that's okay. So here's vector A, and here's vector B. Am I still on screen? No, barely. Okay. And then you say, okay, here's A and B. Remember, the vector arithmetic says hook the vectors up head to tail. You know, draw the first vector and then the second vector, and you know, from there. And notice that, see, like here's 30 degrees, but where's 70 degrees? Well, you draw a little XY axis for B, and you say, okay, well, this is 70 degrees. And this is just a little hand sketch, so it might be a little bit off, but here's my answer from where A started to where B ended, right? And so you draw a straight line from here to there, and that's my resultant vector. And I might look at it and say, okay, it's a little bit longer than 20, but it can't be greater than 30, and it's going to be a little bit less than 30, right? Because these didn't line up. A and B have to be in a straight line in order to get to 30 meters. So I'm going to guess R, just from my sketch, I'm going to say R is equal to, let's say 26, maybe 27 meters. And at what angle? Well, if this is 30, 40, 50, maybe 50 degrees. And this is just an estimate. I should make this approximately. So this is just from a sketch. So I'm looking at what my answer should be from my graphical little sketch. And if you wanted to get a protractor and ruler and make it perfect, you're probably going to get a slightly different answer than that. But how do we add these two vectors together mathematically? Well, let's do that. Well, here's what a student will do. Here, think about this. You add them together. Sorry, I need some water. And please don't do this. Don't even write this down. It'll break my heart if I see it in your notebook. Oh, well, 20 meters plus 10 meters, that's 30 meters. And then 30 degrees plus 70 degrees, that's 100 degrees. There's my answer. No, no, no. Bad student. Okay. Don't do that. If you do this, 5 points will explode from your test score at the speed of light. And a little piece of me will die. Okay? Little hemorrhage in the brain. So no, 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 no. You cannot add vectors together when they are in this form. What do we call this right here when you give a magnitude and an angle from your math classes? What do we call that? Polar coordinates. Do you remember polar coordinates? Yes, these are in polar coordinates. Polar coordinates. That's when I give a magnitude and an angle. Am I still on screen? Yes. Magnitude and an angle. Okay, and the angle, how do we measure the angle in polar coordinates? We always measure the angle from the positive x-axis, so here's positive x-axis, and we rotate counterclockwise if it's a positive angle. Now this is all arbitrary. All the mathematicians got together and decided this is how we're going to do it. And if we rotate clockwise, here's the positive x-axis, and if we rotate the angle clockwise, that gives you a negative angle. Right, so this would be a negative angle. If I said negative 30 degrees, it would be, down like this, okay? And you remember this from your math classes, I hope. So, I'm going to give you vectors to add together, and I'm going to give them to you in polar coordinates, and you have to add them together mathematically. So what do you have to do? In order to add them mathematically, you must convert them to rectangular coordinates. Rectangular coordinates. Yeah, and the irony is we're going to make a triangle out of it. Let's take a look at vector A. 20 meters, 30 degrees. Okay, so here's vector A. And here's 30 degrees. And here's what I want you to see. I could say to you, hey, starting here, go 20 meters at an angle of 30 degrees. And you could do it. And that would perfectly describe your displacement vector from here to here. But couldn't I also say, hey, go this much in the x direction and go this far in the y direction? And look where I get. I get to the same spot. Have any of you ever played Battleship? It's kind of like Battleship. You give rectangular, those are rectangular coordinates in Battleship. Okay, so you go this far up and this far. And it turns out that we can add vectors in rectangular coordinates. Let's take a look at this picture over here, which has got kind of messy. I'll probably redraw it here, but I'm in a hurry, so I'm just going to say, hey, look at, here's A and here's B. Well, look, here's A and here's A. So A goes this far in the x direction, doesn't it? See, this is A in the x. And then then it comes up here. Here's A in the y. Well, what about B? Well, here's B in the x, and here's B in the y. Now, here's what I want you to see. And it's kind of hard to see in this drawing, but if I go A in the x plus B in the x, so I'm just going to take B in the x and put it down here. Do you see that I've gone all the way over to where R in the x is, the resultant value in the x direction? Yes? Does that make sense? Seriously. I mean, I'm really asking. So yeah, I can add A in the x and B in the x together because they're in the same direction. So they just add, like scalars add. What if B went in the negative x direction? That's okay. You can go A in the x minus B in the y. I mean, it's just going to subtract instead of add. Now look at A in the y. Look at A in the y plus B in the y. Well, I'm going to move A in the y over here. A in the y plus B in the y, and that gives me the resultant vector in the y direction. Cool. So all I need to do is figure out the x and y components of my vectors. How do I do that? Well, let's go back to this picture. What involves the magnitude, the angle, and the opposite leg? Well, I'm just going to get to it. Sine theta. Do you remember sine theta? Have you done sine and cosine? I hope so. Sine, by definition, is the opposite leg of a right triangle divided by the hypotenuse. Now I'm just going to write it as A. That's the total, that's the magnitude. That's the 20 meters. So A in the y, therefore, is equal to A sine theta. Right? I just multiply both sides by A to get A in the y. Cosine theta, by definition, is the adjacent leg divided by the hypotenuse. which means that if I solve for a and the x, I get a cosine theta. So if I want to change, if I give you vector A in polar coordinates and I want to change to rectangular coordinates, just say, hey, it's a sine theta, and for the y component, and the x component is just a cosine theta. Easy. Yes? Okay. So, and I can do the same thing to vector B. So now we're actually going to add A and B together mathematically. And let's see. Yeah, I got enough room here. So I'm going to start like vector A is equal to, I'm going to start off 20 meters, 30 degrees, plus B equals 10 meters at 70 degrees. Again, now when you do this and go blah, 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 blah. Don't even try to add them. So what do I have to do? Well, I want the x component and the y component stacked together like this. So this is going to be 20 meters times the cosine of 30 degrees. That's my x component. And then my y component is going to be 20 meters times the sine of 30 degrees, right? And that's going to be my that's going to be vector A in x and y components. And then this is going to be 10 meters times the cosine of 70 degrees, and this is going to be 10 meters times the sine of 70 degrees. So let's actually do the arithmetic here. Try to make it fit. Where's my calculator? Oh no. Here it is. Now make sure your calculator is on. That helps. And then make sure it's in degrees. And I'm going to go 20 meters, 20 times the cosine of 30 equals 17.3 meters. And then the y component is 20 times the, well, I don't need to do that. What's the sine of 30? 1/2. What's 1/2 of 20? 10. This is 10 meters. And then here we have 10 times the cosine of 70. Clear. 10 times the cosine of 70. That's 3.4. And then 10 times the sine of 70. And that gives me 9.4 if I round off. Okay. So now I have converted vector A and B to rectangular coordinates. And I can just add the x components together. So this is 0.7 meters, and this is what's 17 plus 3? 20. So 20.7. So when I add them together, the x component of my resultant vector is 20.7 meters. And then here we have 10 plus, so this is going to be 19.4 meters. You all with me? See, I can just add, if vectors are in rectangular coordinates, I just add their like components. I add their x component and I add their y component. So I could say, hey, vector R, the resultant is 20.7 meters, 19.4 meters. Is that my answer? Sure, that's your answer in rectangular coordinates. But I want you to give me the answer in polar coordinates. So how do I figure out vector R? Right here, this vector R, A plus B equals vector R. How do I figure out what this is in terms of magnitude and direction? How do I figure out its magnitude? Well, if it goes this far in the x and this far in the y, what can I use to figure out what the total length is? Is this Greek guy? Yeah, Pythagorean. Pythagoras' theorem. So the R is equal to the x component squared plus the y component squared. and then take the square root. And let's see what we get. 20.7 squared plus 19.4 quantity squared equals, and then I'm going to raise that to the power of 0.5, and I get 28.3, or 28.4 actually, 28.4 meters. Now that's the length. How do I get the angle? How do I get the angle? I want theta. Well, look what I know. Let's go back to my picture. I know r in the x, and I know r in the y, and I want the angle. What involves the opposite leg and the adjacent leg? Tangent, right? So if I say, well, let me go over here. Tangent theta, by definition, is the opposite over the adjacent. But I want the angle. I know what the ratio is. I want the angle. So what am I going to use? I'm going to use inverse tangent of the x component, the y component, over the x component. Thank you. And this will give me my angle. So 19.4 divided by 20.7 equals 0.937. And then I'm going to take the inverse tangent of that, and I get 43 degrees. So now I can say that vector r is equal to 28.4 meters at 43 degrees. And that's my mathematical answer. Now, how does that compare to my estimate? Well, there's my, let me zoom all the way out here. That's not a great estimate. Not too bad on this. The angle's a little bit off. But it's in the ballpark. It's close. So, here's what you need to do on the homework. And I'm sorry this lecture wasn't long enough. But first, take vector A, B, C, and D, convert them to rectangular coordinates. Then you can do the arithmetic asked for. And I'm going to see if you can do number 7 and number 9 on your own. There's some subtraction there. See if you can do that. And I even have some coefficients in there. So try that. This assignment is... it's going to take you some time to do, so make time for it. And maybe do it over the course of 2 sessions rather than 1. Any questions? You have a question? No questions. Okay, that is all.